viewers, welcome again to today's class. We want to see problems of chemistry. Now, the first question is arrange the isoelectric ions in order of increasing atomic size. Now, you can see this is fluoride ion, this is oxygen, sodium, aluminium, neon, magnesium, and nitrogen. Then, for you to be able to answer this question, write the neutral form of it first. For question number 1, write the neutral form of it. It will give you fluorine. Neutral form means no valency, no power in that element. Oxygen is O, then nitrogen is Na. This is sodium, please, not nitrogen. Then aluminium is Al. Then the next one is neon. And the next one is magnesium. And the next one is nitrogen. Then the magnesium is 12 plus 2 minus 3, 7. This is 10 plus 3, 13, 11 plus 1, 8 minus. We want to write it without the valency, please, so that we will not make mistake. Now, these are the neutral form of this element. Remember, in electrical neutral atom, the number of electron will be equal to number of proton. So number of electron for this will be 9, number of proton will be 9. And remember that the proton is located inside the nucleus of the atom. Then this one, electron equal to 8, proton equal to 8, because in an electrically neutral atom, their numbers must be equal. Then electron equal to 11, proton equal to 11. Electron equal to 13, proton equal to 13. Electron equal to 10, proton equal to 10. Electron equal to 12, proton equal to 12. Electron equal to 7, proton equal to 7. They must be equal. Now, when you have this ion, fluoride ion, the implication is that this is an anion. An anion has tendency to gain an electron. So once this gains an electron, what it gains is that the electron will increase by 1. Electron equal to 9 plus 1, 10. While the proton will retain its number. Then this one, oxygen minus 2, it simply means that the electron will gain 2. This electron will gain 2 extra, making electron equal to 10, proton equal to 8. Then this one, sodium plus. This is a metal, no more a non-metal, so it's a metal. So it will give out its 1 electron, giving electron equal to 10, proton equal to 11. Then this aluminium, they gave us to be this. It simply means it will give out 3 electrons. So if you give out 3 electrons, it will be 10. This proton will turn as 13. Then this neon is a rare gas or noble gas, so it will not give out or collect, so it will retain at 10. Then this one, magnesium, is plus 2, so it will give out 2 electrons, making E equal to 10, then P equal to 12. Then the sodium, this is nitrogen. Nitrogen is minus 3. It means it will get extra 3 to give you E equal to 10, P retain to be 7. Now get the difference. This minus is 1. This minus is 2. This minus is minus 1. This minus is minus 3. This minus is 0. This minus is minus 2. This minus is 3. So which one has the highest number? this positive 3. It means that it will have the highest atomic size. It will be here. So this will be the highest one. The next one following is this. Oxygen. Oxygen is -2 and 8. As you can see, that is the second. The next one is 1. Fluorine. Fluorine is -1 and 9. Okay, it continues. Then the next one is 0. Neon. Neon is 0. 0. Then it continues. The next one is -1. Sodium. Sodium, yes. Sodium is -1. Then the next one, -2. Magnesium. Then 12. Then the next one will be the aluminium. This tells us that the aluminium will have the lowest atomic size, whereas this nitrogen will have the highest atomic size. Hope you understood it. So we go to the next question. The next question says calculate the number of disintegration per second of 1 gram of uranium. Calculate the number of disintegration per second of 1 gram of uranium 232 if half-life is this. Now, the formula to calculate it is minus dN/dt equals to the decay constant times mass times Avogadro's constant all over molar mass. Okay? Now, how do we get this decay constant? We say decay constant equal to 0.693 all over half-life. And what is our half-life? Half-life given to us is in years. We have to convert it to seconds and see how you do it. It says 0.693 all over, you write it in years first, 5.77 times 10 raised to the power of 9, as you can see. Then this is in years. To days, you say multiply by 365.25, that is to days. To hours, you multiply it by 24 hours. To minutes, you multiply by 60. And to seconds, you multiply by 60. So it is already a second, and the answer will now be, if you compute this with a very good calculator, you will be having 3.806 times 10 raised to the power of minus 18 per second. Then we have gotten at this. So what we now need is to remember that your Avogadro's constant is a constant, is equals to 6.02 times 10 raised to the power of 23. So we put everything in our formula. We now say minus dN/dt. We'll be giving you this 3.806 times 10 raised to the power of minus 18 times the mass of the uranium is 1 gram times 6.02 times 10 raised to the power of 23 all over molar mass is 232. So if you compute this with a very good calculator, what you'll be getting is 9876 disintegration per second. Do you understand it? So that is the solution to question number 2. We go to question number 3. Arrange the following orbitals in order of increasing stability. In chemistry, there is what we call m plus l rule, energy of an orbital. This rule states that the higher the energy, the lower the stability. And how do you get the energy? It's from n plus l. And it's also said that the lower the energy, the higher the stability. Now, in this question, in this question, S is denoted to be 0. It has an azimuthal quantum number of 0. P is denoted to be 1. It has an azimuthal quantum number of 1. This is the L. Then let's write it clearly. Then we say the S orbital you are seeing is noted with 0. That is, its azimuthal quantum number is 0. The P is denoted with 1. Azimuthal quantum number is 1. The D is noted with 2. That is, azimuthal quantum number is 2. The F is noted with 3, and so on. SPDF. Now, remembering N plus L rule. This is the energy of an orbital. This formula is used to get the energy of an orbital. Do you understand it? So, what you now do now is, you now say, your N, let's get their energy. 6x. It means that your N is 6 and your L for S is 0. So 6 plus 0 is 6. Then for 5p, it means that 5 plus 1, because your p is 1 from N plus L rule. Okay? That will give you 6. Okay? Then for F will give you, N is 4, F is 3. So 4 plus 3 equals to 7. Then what else? 7x. 7x. The N is 7 and the S is 1. 7 plus S is 0, please. S is 0. 7 plus 0 equal to 7. Then the 4D is equal to 4 plus your D is 2 equal to 6. Now, we have gotten our energy. These are the energies of this orbital. 6x, 5p, 4f, 7s, and 4d. Now, you can see there are some that are the same. This 1, 2, 3 have the same energy. Why these two have the same energy? Now, how do you know the one that have lower energy? The one with, when 2 or more orbitals have same energy, the one with lower n is the one that have lower energy. So the implication is that this one have lower n. Between this and this, the one that have lower n is 4. So 4D have the lower energy. Then the one of 5p will follow. Then 6x will follow, because this is the lowest, this follow. Now between these two, this one have the lower energy, 4f, and this one will have the next lower energy, 7s. So the implication is that this one have the highest energy, while this one have the lowest energy, because the lower n is this and the highest n is this. So this is the lower energy. This in the terms of energy. Energy increases this way. Highest energy, as you can see. Then stability increases this way. This tells you that this 4D, which have the lowest energy, is said to be most stable. That is, the one with the most stability is 4D. 4D equal to most stable. Do you understand it? Thank you. We go to the next question. The next question says, which element have diagonal relationship with boron? Let's see. The element that have the same diagonal or diagonal relationship with boron. Okay. For you to solve this question, the elements that fall in the second period are lithium, beryllium, boron, carbon, nitrogen, oxygen, neon. Then the third period, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. Sodium, magnesium, fluorine, neon. So chlorine, argon. So we have this element this way: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Now look at how the diagonal relationship goes. This will go diagonally to this. This will go diagonally to this. This will go diagonally with this. This, then this, then this, then this. You can see that lithium have same diagonal relationship with magnesium. Beryllium have same diagonal relationship with aluminium. Boron have same diagonal relationship with silicon. So the one they ask us is which element have diagonal relationship with boron? We say diagonal relationship with boron, the one that have it is equal to silicon. That is, they have similar chemical properties. That is simple. The meaning of having diagonal relationship is based on the chemical properties. Okay. We go to the next question. So, if they ask you diagonal relationship, which one has diagonal relationship with beryllium? You say aluminium. Lithium, you say magnesium. Carbon, you say phosphorus. Nitrogen, you say sulfur. Oxygen, you say chlorine. Fluorine, then argon. Then, let's see the last question. The last question says, what is the element if n equals to 3 and L equal to 2? M equal to 0, S equal to 1 over 2. This L is the principal quantum number, L is the azimuthal or subsidiary quantum number, M is the magnetic quantum number, and L is the spin quantum number. Now, the principal quantum number is noted with N, the azimuthal quantum number, L, is noted from 0 to N minus 1, then this is magnetic quantum number and this is spin quantum number. So this spin can be moving clockwise or anti-clockwise. So since it's positive, it means it's moving clockwise. Okay? Now let's solve this question. To solve this, since our L is 2, it means that our magnetic quantum number M, which ranges from minus L to plus L, it will become minus 2 to plus 2. And since it is so, now this L, which is 2, remember it denotes orbital D. Orbital D has 5 orbitals. Orbital D have 5 orbitals, denoted this way, according to Hall's rule. 1, 2, 3, 4, 5. Now, the center one will be 0, minus 1, minus 2, 1 and 2. Because magnetic quantum number ranges from negative of azimuthal quantum number to positive of azimuthal quantum number. Since azimuthal quantum number is 2, it means minus 2 to 2. Now, we start assigning our electron. Remember that when the spin moves like this, it means clockwise. And when it moves downwards, it means anti-clockwise. So what you now do is that it will be, according to Hall's rule that says the electrons will enter singly until it's completely filled before it will have a maximum of 2 electrons. So we'll be moving singly in clockwise direction to get to 0. As you can see, since our earth, the spin tells us that it is positive, that is clockwise, it means that this spin should be clockwise. If you come and put the one, this one, you are wrong, because this one is anti-clockwise, that is minus half. So it will return my plus by being positive. So what you now do is that you say you are done. It means it has 1, 2, 3 electrons at the d orbitals. So you now say your n is 3, you write 3, d, then you have 3 electrons, you put 3. Now, what you now do is that since there is already 20 elements before this, or you can put it this way, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. Now let's count the electrons. 2, 4, 10, 12, 18, 20, 23. We'll be having 23 electrons. Now, which element have 23 electrons? From our periodic table, vanadium have 23 electrons. So vanadium is the one that have 23 electrons, and it is the one that is defined by these parameters we have. Thank you for watching the video. Please like the video, send it to your friends and well-wishers.